So today we will going to learn how to solve linear simultaneous equations graphically. So if we are given these two equations, first of all what we do, we convert them into the general linear equation form. So what is the general linear equation form? It is y equals to mx plus c. So first of all, we will convert both of these equations to the general form, and it will become y equals to 2x minus 3, and the second equation will become y equals to minus 3x plus 4. Okay, so you see this c will tell you the y-intercept. And where do we get the y-intercept? When x is equals to 0. So over the graph, the y-intercept will be somewhere here. If I have this linear equations, so um, these are the y-intercepts over here at these points where the x values are equals to 0. Okay, so what is this m? M is the slope, so it can be positive or negative. So slope means the gradient, some people also call it as gradient. This means that it tells you how steeply or how slowly something is increasing or decreasing. So if the slope is positive, this means that the graph is going upwards, and like the slope is increasing. And if the slope is negative, this means that the graph is going downward. So it will be in the graph, it will be for the increasing, the line will be something like this or this with the higher steepness. And if I have another Cartesian coordinate, so the graph for this negative will be like this. Okay, so yes, so let's solve these two equations. um Now we know that for okay, let me take it here. So now we know that from this equation we know that the slope and the intercept. So for this, the slope is 2, and over here it has a positive sign. This means that it is increasing, and the intercept is minus 3 on the y-axis. And for this equation, our slope is negative 3. This means that it is decreasing or falling down, and it has the intercept of 4. So from here, we got these 2 points on the graph where we can um, point these 2 points. So plotting these equations, we need, for plotting these equations, we need 2 points. So in order to plot any straight line, you need only 2 points. Okay, so when you join it with the ruler or with the straight line, it will give you the straight line. Okay, so we know this point, the intercept minus 3 and minus 4. So in order to find 2 to 3 some other points, I'm taking 2 to 3 more points to get our line. So what you do, you make the table. So for the first graph, y equals to 2x minus 3, I have this table. Okay, and in here what you do, you put the values, you put x and y over here, and for all the values of x, when you put in this equation, you get the values of y. So let's suppose if I have x equals to 1. Okay, when I put x equals to 1 in this equation, then y will be equals to 2 minus 3, and it will give me the value y equals to minus 1. So if x equals to 1, then y is minus 1. Similarly, for x equals to 3, you can say, then what will be the value of y? Y will give me, put the value 3 for x, and it will give me 6 minus 3, so y will be 3. Okay, so for x 3, I have y which is equals to 3. So now we know, and for x, when the x is equals to 0, we know that y intercept is minus 3. Okay, so now we know, we have these 3 points or coordinates. We can plot these over here. So I have this graph, and let's point out these points on the graph: x1, y minus 1. So over here, x equals to 1 and y minus 1, so this will be the point for and x equals to 3, y equals to 3. So if this x equals to 3 and y is equals to 3, so our line will our point, I'm making a big circle over here around it, so y will be 3, and with x equals to 0, y is negative 3. Okay, so y negative 3, and over here x is equals to 0. So let's mark it here. Okay, so let's join these 3 points so that we can get a straight line. I'm coloring it with the light green, and join these points exactly at the same where the coordinates are, you know. Okay, so this is the graph in the form of line for this equation y equals to 2x minus 3. Okay, let me remove this. Okay, for the other equation, we have the graph, and let's take the color of it as purple, for example. So I have this, I'm writing it here, 3x, sorry, y equals to minus 3x plus 4. Okay, so this is our new for the second equation. We had the second equation. Make the graph, sorry, make the table to get the values of x and y's. So x is here, y is here. Okay, so we know that for x, for the value of x equals to 0, our intercept is our y-intercept is 4. Okay, so we know this point. All right, so let's take the other point as we have taken for the previous equation. You can take any point. Let's take 1 and 3. I'm taking these. So when x equals to 1 and x equals to 3, then y will be equals to minus 3, 1 plus 4, and it gives me minus 3 plus 4 and gives me 1. All right, so when x equals to 1, y is 1, and for x equals to 3, let's put the value for the x, and you get your answer for y. So y will be equals to minus 9 plus 4, and it gives you minus 5. So for the value of x3, you have value of y which is equals to minus 5. Let's plot these points on the graph. 0 and 4. Okay, x0, y4, so it will be somewhere here. Actually it should be here. Okay, 1 and 1. For x equals to 1, y is equals to 1, so it should be here. Yes, here. And sorry, 3 and 5. X equals to 3 and y is equals to minus 5. So it's here. Okay, so for the line we need only 2 points, but over here we have 3 points. No problem, we can join them with a very straight line with the ruler, of course. Oh, it should have purple color. Okay, join them with the very similar points. Okay, so for the simultaneous equations, for the linear simultaneous equations, okay, your solution is where these two lines are intersect with each other. Okay, you plot the graphs, you plot the lines on the same graph, and you see where these two straight lines cross with each other or intersect with each other. You see this is somewhere here, and let me point that point with the red. So these two lines are intersecting somewhere here, but now as they are not the whole numbers, there some be there must be some decimals. So I was actually comparing this graph with the Save My Exams, but they were giving me a point of intersection over here, which was wrong, and I was trying to prove it that it's right, but this is not right. Okay, so in order to get the exact value, this is how you plot, but you cannot you cannot find out the decimals. You can do actually, if this is 0.1, 0.2, over here this is 0.5, so this come out to be somewhere um, y equals to minus 0.2 and x will be equals to, if this is 1 and this is 1.5, half of it, and this is somewhere a bit a one small block before 1.5, so I guess y will be 1.4. So these are these solutions. So you can, if the graphs are like this in the decimals, you can just cross check them very quickly in just 30 to 45 seconds. So how we can cross check them? So in order to cross check your answer, you can simply solve these two equations. It's your choice whether by doing elimination or by substitution. So I'm doing this with the elimination method because I see that I can simply remove 5 from it by just adding them. So oops, it's 4. So if I just by do by elimination method, I can remove this y, so it will give me 5x equals to 7, and from here x equals to 7 over 5. And if this 7 or 5, you can convert it into this decimal, and it gives you 1.4. So if you convert it, the calculator gives you the value of 1.4, and this is the exactly value of x that I have found over here. And let's put this x value in any of the equation to get the value of y. I have this equation already, so I'm putting the y equals to 2x minus 3. I'm putting the value of x in here to get the value of y, and this will become minus 3 and this will give me 14 minus 15 over 5 and minus 1 over 5 it will be minus 0.2, which is the value of y. Okay, and you can also see that y is minus 0.2, 0.2 actually. So this is how you cross check your question. Now the third thing is that you can also check the whether the line, sorry, whether the slope for these two lines is exactly what is given over here, plus 2 and negative 3. So how can you check it? We know that the value of slope, sorry, the formula for the slope is m equals to, which is the slope, is rise over run. And rise is just like you are rising with the ladder, or you are, you know, going up with the stairs. And run is when you run on the horizontal surface, either you go to and fro. So rise will be equals to y2 minus y1 divided by run is x2 minus x1. So you can put the values and get your slope. So for the green one, I have the slope. You can take any 2 points, okay, and I'm taking this point and I'm taking this point, okay. So if you're going upwards, so y2 will be this. Y2 is 3, and what is y1, which is minus 3. Okay, 1 second. So we cannot take actually the 3 minus 3. Definitely it will always give me the 0 value. So we have to take some other point for it. And let's take this one, okay, this one. So y2 is 3 minus y1 is minus 1 divided by x2 is, for this point x2 is 3 minus, and x1 is 1, right? Yes. So x1 is 1. So this will give me 4 over 2, and my slope for this green one is 2. And you see the green one is going upward, so it has a positive slope, and this slope is also matches with this one. Okay, now let's calculate the slope for the purple one. And what was the equation? The equation was y equals to minus 3x plus 4. Okay, so what you can do, take the slope of it, write the formula, y2 minus y1, x2 minus x1, and from here you can take any 2 points. Let's say this point and this one, okay. So y2 is 4, yes, y4 minus, which is y1 is 1, and x2 is 0 minus, because here the x is 0 and minus this point x is 1. Okay, so this will be 4 minus 1 divided by, it will become 1, so this is minus 3. So you see our slope exactly matches with the given equation. So this is how we solve the simultaneous linear equations graphically.